So, yeah, like my voice is not doing so good, so it's going to sound like a frog is teaching you for the next hour. Didn't even test to see if my pen's working. Hopefully it is. Mr. Keys seems to be back in form. Hopefully I get the right answers. Okay, so it's not working great, but so whatever. Anyway, today's day 8. Day 8 already. Test is coming up at the end of the week. Are you guys excited? I am. Okay, I am. For you guys. Wouldn't be excited for me. So hey, today what we're going to do is learn to solve systems of equations. Now, what I'm certain of is that you all are excited about this because this is what students really, really look forward to. Solving not one, not two, but 3 equations. Does that not sound like a lot of fun to you? You got 3 equations and 3 unknowns, and you got to do a whole bunch of math, and you got to hope you don't make a mistake. And if you do, it's going to be totally wrong, and you won't get the right answer, and it won't check, and you'll be really, really mad. So you got to take care of yourself. No, not take care of yourself. Take care of your precision, and then do some amazing math. Are you guys ready to rock and roll? Would you like to start a little easier? Okay, let's start with the warm-ups then. Warm-up's just designed to get you to remember something you were taught a couple of years ago, and that is working with systems of 2 equations and 2 unknowns. By the way, my glasses are really dirty, so I need to clean them. So hopefully they aren't showing you dirty, because I don't want you to think my glasses are dirty. And I want to apologize about my voice. We had a great soccer weekend. Unfortunately, we lost, but also I'm kind of sick. So here we go. That's enough whining. Let's just take care of these systems. Now, when I look at these 2 systems, I see that everything's lined up. I see the equals are lined up, the y's are lined up, the x's are lined up. I also notice that these 2 things right here are exactly the same. The 2x and the 2x are exactly the same. So what I'm going to do is I'm just going to subtract the 2 equations. That's all I'm going to do, is just going to subtract the 2 equations. So 2x minus 2x, well, those just cancel. 3y minus y is 2y, and 7 minus 3 is 4. Well, clearly then y is equal to 2. Wow, that was easy. Wait, we're not done yet. We've got to find out x. So 2x plus 3y equals 7. I'm going to pop that sucker in there. So 2x plus 3 times 2 equals 7. Oh, yeah. Give me another pack of cigarettes. This is 6, so I'm subtracting 6. 1, so x equals 1/2. I probably should check my answers just to make sure. So I'll write the second equation. 2x plus y equals 3. So 2 times 1/2 plus 2. Does that equal 3? And clearly this is 1 plus 2, and yeah, that equals 3. So it checks. That wasn't bad. Uh-oh, this one's not so good. So this equation, this system, everything's lined up. I got the numbers on top of each other. I got the y's on top of each other. I got the x's on top of each other. But I don't have any matching things. And what I'm actually looking for are what's called additive inverses, like 2x and negative 2x, or in this case 5x and negative 2x. I'm looking for additive inverses. And since I don't have that, what I want to do is try to change one of the equations. Now, 5 and 2, I'd have to change both equations. But if you look at the y's, if I multiply this equation by negative 2, right, this would give me positive 4x. But look what it would give me here. It would give me negative, oh, wait, hold on. I don't want to multiply by negative 2. I want to multiply by positive 2. So this would give me positive 2y right here. And that would be an opposite or an additive inverse of that negative 2y. And you'll see why that's important in a second. So 5x minus 2y equals 4. Now, so long as you multiply both sides of the equation by the same thing, it doesn't change the value. So I'm going to multiply the second equation by 2. So negative 4x plus 2y equals 4. So by doing that now, instead of subtracting the 2 equations, what I'm going to do is add them. Well, here, if I add these 2, I get x. And then this is, oh, these cancel. I add those together. I cancel. So I get x equals 8. Well, I'm not done yet. I got to still mess around and find out what y is. 5x minus 2y is equal to 4. 5 times 8 minus 2 times y is equal to 4. This is 40, so I'll subtract 40. So I get negative 2y is equal to negative 36, or y is equal to negative 18. You know what? That can't be true because it's really humongous. So let me check. I got to check this. Let me check. So negative 2 times 8. I'm using the second equation to check, by the way. Negative 2 times 8 plus a negative 18. Ooh. Oh, this should be positive. Ah, see? Look, I did make a mistake. Divided by negative 2, divided by negative 2, I should have gotten a positive 18. So plus 18 equals 2. So negative 16 plus 18 is, in fact, 2. So my answers are x equals 8 and y equals 18. All right. Pause this for a second. Sorry, guys, I just had a little coughing attack. Man, what's this problem? All right, this is a crazy problem. All right, this sounds really hard, but it's actually not. It's a little word problem. We hate word problems, Mr. Krause. They involve words and math. When am I going to ever use this stuff? Ooh, scientists may use this stuff to create equations that would help them solve scientific questions or problems, like this one right here. We're talking about a scientist who wants to create a 120 milliliter solution. So that's his total milliliters. He's going to do it by using, that's 30% acidic. So we're going to combine a 20% solution that's acidic and a 45% acidic solution. And then what I want to end up with, again, is that 30% solution. So let's think about what my variables are going to represent. Let's let x equal number of milliliters of, 20% solution. And let's let y equal the number of milliliters of the 45% solution. Now, if 30 was halfway in between these, you would just use 60 of each, right? But 30's not. 30's a little bit closer to this one than it is to this one. So clearly I'm going to use a little bit more of this one and less of this one. So if you end up with this to be, this should be greater than 60 and this should be less than 60 when I'm done. Now that's just thinking about things, right? Because if it was right smack dab in the middle, let's say they wanted a solution, what's smack dab in the middle between 30 and 45? 20 and 45. What's the difference? 25, 12 and a half. 32.5 said they want a solution that was 32.5% acidic. Well, that'd be right in the middle. You just mix equal portions of each one in there and be done. But I don't. What I need to figure out, though, is how much solution is going to be acidic when I'm done. So I want to know how much of that acidic stuff do I need. So what I'm going to do is I'm going to take the 120 milliliters and I need to multiply it by 0.30. Now, if you do that on your calculator, it'll tell you there's 36. So there's 30. Oh, man. Whatever. All right, so what I'm going to do is I'm going to mix some of this x plus some of this y, and it's going to add up to 120 milliliters. So that's my first equation. My second equation is going to be 20%. Which one? This is 20%. So 0.2x, that's 20% solution, plus 0.45y, that's the 45% solution. And what I want that to end up doing is, so what you're going to do is 20% of this solution is acidic or acid. 45% of this solution is acidic or acid. And whatever I want that to end up being 36, I want that to end up being 36. So I'm just going to match these. What I'm going to do is I'm going to take this one and I'm going to multiply it by negative 0.2 because that would give me additive inverses right here at the beginning. So negative 0.2x plus excuse me. Why did I say plus? Guys, brain's not functioning, neither is the voice. Minus 0.2y is equal to, I believe that's 24. I should probably bust up my calculator so I don't make dumb mistakes. Oops. And I haven't worked this out yet before, so I don't know what's going to happen. Hopefully I get it right. Calculator up. So I'm sure that's right. And then the other one's going to be 0.2x plus 0.45y equals, oh, it should be negative, right? Sorry, because we're multiplying by negative 0.2. Let me just make sure. Come on. So 120 times negative 0.2 should be negative 24. Good. Okay. Equals 36. So when I add these two equations up, that's what I'm going to do. I'm going to add. These go away. That's what we want to happen. And we get positive 0.25y equals 12. Divide by 0.25, I get y equals 48. So if I plug that back in my first equation, I say, okay, x plus y is equal to 120, or x plus 48 is equal to 120. And I subtract, I get x equals, see, that's 80, 72. So what I need, and I apologize, I need 72 milliliters of 30% solution. And I need 48 milliliters of 45% solution in order to do this problem, or in order to satisfy this. All right. Sorry. Hope I can manage through the rest of this stuff. Next problem. How many problems we got? I hope there's not too many. I think there's only 3. Maybe there's 4. No, I think there's 3. We got 3 problems. Long enough. All right, kids, we're going to do 3 problems. So now, it doesn't matter what, I'm going to teach you a method to solve these 3 systems. You have 3 equations, and you have 3 variables you need to find out. Now notice I'm giving you an entire page to do this one problem. So it's going to require some work. So what we're going to do is, the first thing we're going to do is solve for one variable. Doesn't matter which. In this case, I'm just going to solve for, which would I solve for? I solve for this one. I use this one just to follow my thoughts. So 2x plus 3y minus z equals 5. What I'm going to do is I'm going to switch these two sides. They just change signs, remember? So this is 2x plus 3y minus 5, when that 5 comes over, equals positive z. Now, why did I do that? Well, because everywhere I see a z, it can now be represented or equals 2x plus 3y minus 5. So this z and that z can be replaced. It's going to get worse, kids. So hopefully I get through this quick. Sound like your 80-year-old grandfather's been smoking for his whole life. So 4x minus y minus, we'll do this using parentheses, 2x plus 3y minus 5 equals negative 1. That's just this equation right here. Let me clean this up. 4x minus y minus 2x minus 3y. What am I doing? I'm distributing this negative. Plus 5 equals negative 1. Now I'm going to combine everything and move that constant to the right. So I get 2x, putting the x's together, minus 4y equals negative 6. And that's one of my equations I'm going to use. So now what I'm going to do is take it and plug this thing into this equation. This equation's got a plus. It's a little bit easier. So x plus 4y plus 2x plus 3y minus 5, in this case, equals 12. Sorry. If I have time, I'll cut out my coughing and wheezing. Probably won't have time. Since this is just a plus, I'm just going to combine everything. 3x plus 7y, and bring the 5 over, equals 17. So there's my second equation. Now, these are the two equations I'm going to use now. So 3x plus 7y equals 17. And 2x minus 4y equals negative 6. So now I'm looking for a pair of opposites, or an easy thing I can make a pair of opposites. So I can't make a 2 a 3, and I can't make a 4 a 7. So that's not really that easy. So if you remember what I taught you in 9th grade, or for those that didn't have me, what we're going to do is we're going to switch these first two numbers. We're going to put a 2 here, and we're going to 3 here, but we're going to make this one negative. Now by doing that, this gives me positive 6, and this gives me negative 6. This is called the elimination method. We're now going to eliminate x. And the only way to do that is to compare additive inverses, or opposites. So I get 6x plus 14y equals 34 in the first equation. And in the second equation, I get negative 6x plus 12y equals 18. These now cancel because they're additive inverses when I add. This is 26y equals 52. Divide by 26 and I get y equals 2. Well, I'm 1/3 of the way through now. I have to find all three of these. So what I will do now is I'm going to bring this one off to the side. I'm going to go, okay, 3x plus 7y equals 17. I'm going to sub this puppy in for y. So 3x plus 7 times 2 equals 17. Subtract this 14, because this is really 14. So I get 3x is equal to 3, or x is equal to 1. Now I'm 2/3 of the way through. Now what I got to do is I got to grab this crazy thing and figure out what z is equal to. Because z is equal to 2x plus 3y minus 5. So z is equal to 2 times 1 plus 3 times 2 minus 5. So z is equal to 2 plus 6 minus 5, or z is equal to 3. Check my work. So those are my three answers. Now, I really should check my work. Now, you got to check, this is the hard part, you got to check it in all three equations. So my first equation, let me take it off here, is, if I go back up, it's 2x plus 3y minus z equals 5. So 2 times 1 plus 3 times 2 minus 3 equals 5. So this is 2 plus 6 minus 3 equals 5. And that's 8 minus 3. That's equals 5. It's getting worse. My second equation was 4x minus y minus z equals negative 1. So this is 4 times 1 minus 2 minus 3. Does that equal negative 1? Well, this is 4 minus 2 minus 3 equals negative 1. And that's 4 minus 5 equals negative 1. That checks. And my final equation is x plus 4y plus z equals 12. 12. So x is 1 plus 4 times 2 plus 3. Does that equal 12? Not 18. That's a 12. 1 plus 8 plus 3, that's 12. Done. All right, kids, I've got to pause so I can go get something to drink because my throat's killing me. All right, kids, when my throat hurts and I sound like a frog or an old man's drinking, or smoking, not drinking, I drink. By the way, this is Squirt. Great stuff. Can't drink my Dunkin' Donuts or my Brewer's Bagels because, well, I ain't driving from there. Plus, it's late at night. I'd be up all night, And then I'd be cranky in the morning. You guys don't want me to be cranky, do you? All right. Ooh, this one looks easier, actually. All right, let's see. All right, the reason I said it easier because this equation only has two variables, which means in this equation there is no, R value? So let's see. I would say then S plus U equals 4. Again, we're going to solve for one variable. S is equal to 4 minus U. So everywhere I see an S, I can replace it with 4 minus U. Not an S. What? Oh, this shouldn't be an X. This shouldn't be an X. I hope I printed this differently. This is an S. Sorry. So this is 2S. And this is S. So what we're going to do is we're going to replace it with 4 minus nu. You got to be careful of that minus sign, okay? So all right, here we go. So R plus 2 times S. S is 4 minus U. Minus U equals 8. Let's clean this up. R plus 8 plus 2U minus U equals 8. If I get through this problem without making a mistake, you guys can just call me your hero. I don't know. R plus U equals 0? I don't know what I'm doing. Hold on. I gotta look at my notes. I found my mistake. Like I said, if I get through this thing without making any mistakes, this should be minus 2U. I knew something, and it's just that small mistake. That's why I want to make sure I check my notes. If I make a small mistake at the end, I'm done, and I don't want to have to redo the problem because, I'm barely going to make it as we see. So R minus 3U, and then I'm going to subtract this 8 equals 0. So there's one of my equations I'm going to use, which is nice. That's not bad. So now we're going to rewrite the second equation. Let's see if I can do this without making a mistake. R minus 4 minus U equals 2. Well, something weird's about to happen here. This is R minus 4 plus U minus U equals 2. Well, these cancel. And if I add this 4 over, I get R equals 6. Well, that's gorgeous, man. I don't even have to do much work because now I can plug that puppy right into there. So I get 6 minus 3U equals 0. I'll bring the 3U over only because I like having it positive. And I get U equals 2. Bam. Done with that. Now I can plug that into this equation and figure out what S is. S is equal to 4 minus 2, and S is equal to 2. So S is 2, U is 2, and R is 6. I still got to check my equation. So I'm going to do that down here. Don't want to be lazy. My first equation was modified, of course. R plus 2S minus U equals 8. Now, I forgot what they were. R is 6, and S and U are both 2's. So this is 6 plus 4 minus 2 equals 8, and of course that's 10 minus 2 is 8. My second equation was S plus U equals 4. Well, S is 2 and U is 2. That's an obvious one. And my last one was R minus S minus U equals 2. 6 minus 2 minus 2 is 2. 6 minus 4, ka-ching. That was an easy one, kids. The next one won't be. So what the heck is this? So what I want to do, this one's going to be tricky. It says find the equation of the form y equals ax squared plus bx plus c that satisfies these 3 points. So what's going on is this. You have a pair of axes and you have a parabola. And these 3 points are on it. And I need to find that one parabola, that one A value, that one B value, that one C value. And there might be more. I don't think there will be more than one. I think 3 of these things would be very distinct to make a parabola. That would give me these 3 points. Well, let's see what we have here. For each of these, we have an X and a Y, correct? So let's see if I can create an equation, and let's see if you can see where this comes into play. So on the first one, I get y equals, so this is y equals ax squared plus bx plus c. So now we're going to use the point 1, 6. 6 goes in for y, and 1 goes in for x. You guys think I don't need a new computer? Look at that thing. As soon as I'm 15, 20 minutes into a video, it slows down. And it's dying on me. 6 equals, this is just A plus B plus, this should be C. C. So there's your 3 variables. Your 3 variables that I don't know are A, B, and C. So that's equation number 1. So this time, I actually have to create my equations. They weren't given to me. So now I'm going to use the point. It's 320. Not 420, you crazy fools. So 20 is equal to A times 3 squared plus B times 3 plus C, right? Because it's x squared and x. So this is 20 is equal to 9A plus 3B plus C. There's my second equation. This was going to be a beast of a problem. Now I'm going to do the problem. Last one was easy, right? And then I get to the hard one. -2, 15. So 15 goes in for y, and -2 goes in for x. So that's -a, -2 squared, plus b times -2 plus c. So this is 15 is equal to 4a minus 2b plus c. There's my third equation. So now those things that I just circled right there, those are like me giving you the 3 equations. Little squirt. Man, tastes good. Hurts my throat. All right, so I'm going to solve this one for C because I want to eliminate C. Because remember, that's still the same goal. So C is equal to, I'm going to move this over. Just did a backwards arrow somehow. So 6 minus A minus B, because I just moved the A and B over. So this is C. So I'm going to replace this, and I'm going to replace this with this. And I'm going to create 2 new equations here. Let's go green. So 20 is equal to 9A plus 3B plus 6 minus A minus B. 20 is equal to 8a plus 2b plus 6. I should have moved the 6 over immediately. So 14 is equal to 8a plus 2b. Boom. There she is. Now, I want to work my magic with this equation. So 15 is equal to 4a minus 2b plus, and remember, this is what we're subbing in. We're subbing in this 6 minus a minus b. This is going to get subbed in here for the c value. So 6 minus a minus b. So let's see if I can do this all in one foul swoop. This is going to give me 3a minus 3b. And if I move the 6 over, I get 9, right? We're going to subtract 6. So 3a minus 3b equals 9. Let's see if I had those right equations. I haven't made a mistake because I don't want to continue. If I did, 8, 2, 8, 2, and 14, and 3, negative 3, and 9. Perfect. So let me write those two on top of each other. We'll do this in black. So 14 equals 8a plus 2b, and 9 is equal to 3a minus 3b. All right, so what I'm going to do is I'm going to multiply this equation by 3 and this equation by 2, because this would give me 6 here and negative 6 here. And that's what you want, a pair of additive inverses. So 42, remember, everything gets multiplied. So that gets multiplied. Then I got 24a plus 6b. Now I'm going to distribute the 2. 18 is equal to 6a minus 6b. And we got our additive inverses there. That's what we're looking for. These cancel. And so I end up with 60 is equal to 30a, or a is equal to 2. 1/3 of the way there. I'm actually like 80% of the way there, but that's one of the three answers. So I got a equals 2. So let me rewrite this equation. 9 is equal to 3 times a, well, a is 2, minus 3 times b. So this is 6, so I'll subtract 6. So I get 3 is equal to negative 3b. Divide by negative 3, I get b equals negative 1. There's my second answer. I'm like 30% of the way through. So now what I got to do is I got to take this c thing, this thing right here, bring this down, and c is equal to 6 minus a minus b. Well, a we determined was 2, and b we determined was negative 1. So c is equal to 6 minus 2 plus 1, or c is equal to 5. Now, bust back out the black pen, and we got to check our work. Yes, you have to check your work. Well, we're going to check it into two equations. Actually, what we'll do, you know what we'll do? We'll check this graphically. So what our equation is, and our final goal is to create this equation. Our equation is 2x squared minus 1x plus 5, right? Because remember, this is A, this is B, and this is C. Wow, you know what a great check for this would be? Graph it. Let's see what it looks like. If it plots through those points, let me do this. All right. So let me type this in. We've got, my head's probably in the way over here. About as high as I can get that. Shrink my head down. All right, so what I'm going to do is start typing over here. 2x squared. This is a great, easy check. Minus x plus 5. Enter. Now, I don't really care what that looks like. What I really care about is this table. Now, remember, the 3 points were 1, 6. There's 1, 6 right there. See it? 1, 6. 320. There's 320. And we need one more. If we get this next one we're working, we're right. We got negative 215. And there it is, negative 215. That check couldn't be any easier. Just throw them in on the calculator. You're done. All right, kids, that's it. That's all she wrote. I'm not sure how long that lasted. It was long for my throat. Hope you appreciate me working through my pain. If you like the video, please hit like. If you want to subscribe, hit subscribe. If you haven't hit subscribe and you're using my videos, please do so. It helps me out a little bit. I got some donation things. You can throw me $1 or $2. Give me a new computer so I can stop with this. I need a new pen too. My pen, see my pen tip? It's about to die. But anyway, all right, guys, it was a lot of fun. No, it wasn't. Not at all. No. And I hope you appreciated solving 3 systems and 3 unknowns. Yeah, right. But anyway, I hope you learned something. Peace out. Test is on Friday.